Hello everyone. Now again I am here to represent on the topic increasing and decreasing for grade 12th. This is an application of derivative. Now what is increasing and what is decreasing? In life so many up and downs are there. So if we are getting something something beyond our expectations, then it is at the time increasing, and if we are losing something, then I think it is the decreasing. So increasing means all the time we are going to upward and upward and upward, and decreasing means most of the time we are going to the downwards. So increasing and decreasing, if we are go the Hindi meaning, ऊपर जाना और नीचे गिरना. तो increasing and decreasing in terms of graph, suppose y equal to fx. This is the real valued function. Now think about this graph. Here the value of x is x1, value of x is x2, value of x is x3. Means as soon as x is increasing, then corresponding values of y. This is y1, this is y2, this is y3. Now this coordinate will become x1, y1, it will become x2, y2, and it will become x3, y3. As soon as x is increasing, y is as well as parallel to x is increasing. जैसे जैसे x हमारा increase हो रहा है, in the same process y is also going to be increase. Increase in the value of x, it means increase in the value of y. Then graph of this function is known as the increasing graph. Or we can say y equal to fx. This is an increasing function. Now another one. This graph. Now this graph shows that from upward to downwards. From upward to downwards. Here the value of x is x1, value of x is x2, value of x is x3. Corresponding values are y1, y2, y3. It means these coordinates are x1, y1, this is x2, y2, and this is x3, y3. Here, what we are going to observe? X is increasing, but parallel to y is decreasing. X is increasing and y is decreasing. Then graph of the function is known as the decreasing graph. Decreasing graph. One is going to be increase, another is going to be increase, then it is increasing graph. One is going to increase and another variable is going to be decrease, then it is the decreasing graph. Now suppose this one point is x and the second point is x plus h, where h is the slightly close to the x, and corresponding values are fx and fx plus h. Means these are the two coordinates. One is x comma fx and the second one is x plus h comma fx plus h. Now from the first order derivative, f dash x is given by limit h approaches to 0, fx plus h minus fx upon x plus h minus x. This x and x is going to be cancelled. Now fx plus h minus fx, it will become to be positive because a value of increasing graph y always becomes to be more than the previous values. So fx plus h is greater than the fx. It means for an increasing graph, a value of f dash x must be greater than 0. And for a decreasing graph, value of f dash x must be less than 0 because here fx plus h is greater than fx. But here in this graph, fx plus h is less than the fx. So if the graph of the function is increasing graph, then their derivative is positive. And if the graph of the function is decreasing, then derivative must be the negative. F dash x is positive, then increasing graph. F dash x is negative, then it is decreasing graph. Now, this is totally increasing. Here, there is no constant position in the behavior of the graph. Graph of the function is directly strictly increasing, and here it is the strictly decreasing. Sometime we are able to find out the graph of this situation. It means for the time being part, graph of the function is parallel to x-axis. From this point A to this point B, what we observe? Graph of the function is increasing. From A to B, graph of the function is increasing. But for the time being in between these two positions, it will remains constant height. So this is known as the increasing graph. And what is the difference between first and this one, third? First one graph, it is totally strictly increasing, means there is no constant position. But in this graph is increasing. But for the time being, it remains constant. So for this kind of function, derivative of fx is greater than equal to 0. Similarly, this graph from A to B, it is decreasing. From A to B, this is decreasing. Here it remains constant. So here the derivative is less than equal to 0. If value of a derivative is greater than 0, then it is strictly increasing. If value of derivative is less than 0, then it is strictly decreasing. If it is greater than equal to 0 or less than equal to 0, then it is increasing and decreasing respectively. Now, some questions are on this topic. Here it is a graph fx equal to 2x cube plus 9x square plus 12x plus 20, where x belongs to R. Now this is the question, fx equal to 2x cube plus 9x square plus 12x plus 20. This is the cubic equation. Now, if we will draw the graph of this function, then how much part on the number line, real number line, in that part it is increasing or decreasing? Means on the number line, how much segment is there in which the graph of the function is increasing and in which the graph of this function is decreasing. Now, what is the concept that I have discussed with you? We have to find out the derivative d over dx of fx. This is d over dx of 2x cube plus d over dx of 9x square plus d over dx of 12x plus d over dx of 20. Use d over dx x to the power n equal to nx n minus 1, means derivative of x to the power n. Now it will become to 6x square. It will become to 18x. It will become to 12. And the constant for the constant, it will become to 0. Now f dash x will become to 6x square plus 18x plus 12. Now from this part, we have to decide the range of the function for increasing interval and decreasing interval. For increasing part, derivative of f dash x must be greater than 0 or equal to 0. Strictly or without strictly. Now 6x square plus 18x plus 12 greater than equal to 0. Here 6 is common, so we can divide it by 6. Now x square plus 3x plus 2. It is greater than equal to 0. Factor of this are x plus 1 into x plus 2. Now these are the two different factors and product of this factor is 0. If product is 0, then either both factor are positive, positive and positive product is 0, negative and negative product is 0. So we can use either this one or we can use baby curve method. What is the baby curve method? Find out the points where derivative will become to 0. Those point where f dash x equal to 0. X plus 1 into x plus 2. It will become to 0 at x equal to minus 1. It will become to 0 at x equal to minus 2. Now represent these point on the number line. Minus 2 and minus 1. Now consider one value which is greater than minus 1. Consider one value which is greater than minus 1 and find out this product is positive or negative. Consider one value of x which is greater than minus 1 and find out the product of x plus 1, x plus 2. It is positive or negative. Suppose we have taken 5. Then it is 5 plus 1 into 5 plus 2. Now it will become to positive. So it will become here positive sign. Positive sign means in this interval, graph of the function is increasing because the derivative is positive. Took another value in between minus 1 and minus 2. Suppose we have taken 0. Then this is 0 plus 1. Sorry, minus 1.5. Then minus 1.5 plus 1 and minus 1.5 plus 2. So this factor is minus 0.5 and this is 0.5. Now it will become to negative. Similarly, we took the another value. Here it will come to positive. Then positive part it will always consider as the increasing interval and negative part always consider as the decreasing interval. Then what will be the range? increasing interval, -1 to infinity, and minus infinity to -2. -1 to infinity, this part and this part. It will come to the increasing interval, and for the decreasing interval, -2 to -1, this part. Means on the the whole number line is divided by the three parts. Minus infinity to -2, it will goes to the increasing interval. -2 to -1, it will goes to the decreasing interval. And -1 to infinity, it will goes to the again increasing interval. So this is the concept regarding the increasing and decreasing function. Thank you.